Today we're looking at section 6.2 and seeing what happens when we draw a bisector inside of a triangle. The first vocabulary word that we need to learn today is the word concurrent. So when three or more lines, rays, or segments intersect at the same point, they are called concurrent. And they meet at the point of concurrency. So the point of concurrency is just where they all intersect one another. In a triangle, the point of concurrency for the perpendicular bisectors is called the circumcenter. So we'll have a theorem about the circumcenter. So first of all, here's a triangle. And the idea is that PD, PE, and PF are all perpendicular bisectors, right? And what we want to do is we want to see where do those perpendicular bisectors intersect. In other words, what is their point of concurrency? So if you have a point of concurrency of perpendicular bisectors, the vocabulary word is circumcenter. It's called the circumcenter. So PD, PE, and PF are all perpendicular bisectors. The place where PD, PE, and PF all intersect each other is their point of concurrency, or the circumcenter. And the circumcenter has one notable property, and that is that the circumcenter is equidistant from all the vertices of the triangle. So then, if PB, PA, and PC are all the exact same lengths, then they work a little bit like radiuses, where P would be the center of a circle. So you can see why this is called the circumcenter. The circle is going around the triangle, so it's circumscribed around the triangle, and P is the center. So it's the circumcenter, or the center of the circle. This helps me remember that the circumcenter is equidistant from the vertices, because centers are equidistant from all the sides of a triangle, all the edges of a triangle. Okay. So the circumcenter P is equidistant from the three vertices. P is the center of a circle that passes through all three vertices. So the way this is going to look when you have different types of triangles, right, is a little bit like the worksheet that you worked on at the beginning of class where you were constructing the perpendicular bisectors. So the location of the circumcenter is going to depend on the type of triangle you have. So you want to get out your circumcenter page. You already constructed the circumcenter for an acute triangle, the circumcenter for a right triangle, and the circumcenter for an obtuse triangle. So in your summary, you'll want to write down these. If the triangle is acute, the circumcenter is inside. If the triangle is a right triangle, the circumcenter is on the triangle, right? In other words, it's on the hypotenuse, right there. If the triangle that you're finding the circumcenter of is obtuse, then the circumcenter will be outside the triangle, right? So P inside for acute, P on the triangle for right, and P outside the triangle if the triangle is obtuse. And again, P is the radius of the circle that goes around the triangle and has all three vertices of the triangle falling on the circle. So the word circum, right, as a prefix for words means to go around. So think of all the words you can think of that starts with circum, like circumnavigate means go around the world. Circumvent means to go around a topic that someone's talking about, like in a discussion. Circumference, right, means to measure around. And then, of course, scribe means to write. So we're writing or drawing the circle around the triangle. So, circumscribing a circle about a triangle. So if we want to draw a circle that goes around this triangle, the first thing we're going to have to do is draw the perpendicular bisector of AB. Okay, so I'm using my compass to find the perpendicular bisector. There's the perpendicular bisector of AB. Then I want to draw the perpendicular bisector of BC. So again, I would be using my compass to do this. There's the perpendicular bisector of BC. And that makes this guy right here the circumcenter. So now I can place the point of my compass here and open up my compass so that it goes out to A, B, and C, right? And they should be equidistant from all of those three things. And now when I get ready to draw, it should be a perfect circle which goes all around A, B, and C. Let's see if I can do it. Okay. So that's what your circumcenter is going to help you do. It's going to help you find the center of the circle so that you can open up your compass to any one of the three vertices, go all the way around, and you should notice that all three vertices of your triangle are on the circle. So let's look at how we would solve some problems using the circumcenter. So we're told that G is the circumcenter. So if G is the circumcenter, then it's equidistant from the three vertices, A, B, and C, which means GC equals GA, which equals GB. Right? So if GC is 9, then of course GA is 9, and so is GB. So let's look at the next one. It says, given BG is 2x minus 15, what value of x makes G the circumcenter? So remember, in order for G to be the circumcenter, this distance has to equal this distance, has to equal this distance, which means GA has to be 25, GB has to be 25 because GC is 25. Knowing that, I can set 25 equal to 2x minus 15 and solve for x. All right, let's take a look at one in the coordinate plane. It says, find the coordinates of the circumcenter of the triangle with the following vertices. So I'm going to plot my points, A, B, and C. There's my triangle. And remember, I need to find the perpendicular bisector. You don't have to use a compass if you're graphing in the coordinate plane, because you should be able to just count boxes. Remember, it's the perpendicular bisector, so it's going to pass through the midpoint and then have the negative reciprocal slope. So it should be easy to find the midpoint of BC, and then the slope's just a vertical line, right? So there's my perpendicular bisector for BC. Okay, and I can do the same thing for AB. The perpendicular of bisector of AB should be passing through the midpoint and also perpendicular slope, so a horizontal line. Okay, so there's my circumcenter where the two perpendicular bisectors intersect, and that's it. That's all I had to do. All I had to do was find the coordinates of the circumcenter. So the circumcenter is at the intersection of x equals 3, the perpendicular bisector for BC, and y equals 1, the perpendicular bisector for AB. So why don't you try example 4 on your own? You can pause the video now, and then you can resume the video and check your answers. So first I found the perpendicular bisectors for BC and AB using the midpoint and either a horizontal line or a vertical line so that they would be perpendicular. I looked for their point of concurrency, which is point C, and C had coordinates 2, 1. Okay, so just as a triangle has 3 perpendicular bisectors, every triangle also has 3 angle bisectors. So this was the backside constructions that you did at the beginning of class. The point of concurrency for the angle bisectors is called the incenter. And notice this time the circle that we drew is in the triangle, incenter, versus around the triangle, circumcenter. So for any triangle, the incenter always lies inside the triangle. And that makes sense because the circle that we're going to draw is also inside the triangle. Okay. So again, we're looking at angle bisectors instead of perpendicular bisectors, and it's causing the circle to be drawn inside the triangle as opposed to around the triangle. So we get an incenter instead of a circumcenter. And what we notice for this circle is that instead of being equidistant from the vertices, the circle is now equidistant from the sides of the triangle. Okay, so the incenter is equidistant from the sides of the triangle, and that's this theorem right here. The incenter of a triangle is equidistant from the sides of the triangle. You have to be kind of careful when you notice in this picture that there's a bunch of perpendicular angles, and that's because remember that when we measure distance, we also always measure distance using perpendicular lines. So you'll always see perpendiculars there as a way of showing you that that's a measure of distance to the sides. So what does that mean about AP, BP, and CP? They're all angle bisectors. So notice that I marked all the angles in the triangle being bisected. P is the incenter, right? So P is going to be the center of a circle. And that makes PD, PE, and PF all act like radiuses. And then we should be able to draw the triangle. We should be able to draw the triangle in there. Take that off of there. Okay, so there's my incenter. It's equidistant from the sides, and there's the circle that I can draw. So for my construction, for inscribing a circle within a triangle, right, I'm inscribing. That's the clue right there. If you're inscribing, then you want the in-center. And if you want the in-center, then you're working with angle bisectors. So remember how we come up with an angle bisector. We place an arc through the angle, angle A. We place our compass on the intersection points here and here, and then we arc outward. So we're looking for the intersection point. Then we're going to link the vertex back to our intersection point, and there's our first angle bisector. So that's the angle bisector of A. Now we need to repeat this process and find the angle bisector of angle C. So again, arc through C. Place your compass at the places where the arc intersects the angle. Arc out. When you find that intersection point, connect it back to C. So there is the intersection of your two angle bisectors. We'll call that point D. So D is now the center of my circle. And remember, I want to make the circle fit inside the triangle. So when I measure my radius on my compass, as I'm getting ready to measure it out, I'm going to make sure that my compass opening is just as wide as the distance from the incenter out to the edge of my triangle. So a couple of example problems for incenter. Find the length of PS. In this case, it should probably tell you, oh, it doesn't tell you. It doesn't tell you P is the incenter, but Because all of these lines, PD, PE, PF, are all angle bisectors, you should be concluding that P is the incenter. And that means that P is the center of a circle, which fits inside the triangle, making all of these guys PS, PT, and PU radiuses. And that means that PS has to be equal to PU, and that means PS is 8. Okay, let's look at the next problem. They tell you P is the incenter, and that means that PJ and PL have to be congruent. To PK. These are all radiuses. So I should be able to set 4x minus 8 equal to x plus 11 and solve for x. Now it says solve for PK, so I have to plug it back in, and I find out that PK is 52.